Today, America's space program is alive and vital, and it's filled with people like many of you who sit in this audience, or people that you've been seeing on television and you're going to see right now, because we have a special treat that I'm not sure Senator Glenn, he probably is beginning to get a hint that something funny is going on here.
Something's amiss.
But this is an honor for me to be able to introduce Commander Dan Burbank and Flight Engineer Don Pettit live from the International Space Station to have just a chat with the Senator. So, crew, how do you read me?
Charlie, we've got you loud and clear. Welcome aboard the International Space Station.
This is absolutely incredible.
I'd just like to say that we know you have an awful lot on your plate for the next couple of days, and we're delighted just to get a chance to be here at the opening and to maybe just take a few moments to commemorate Senator Glenn's flight. 50 years ago today, Friendship 7 was orbiting planet Earth, and that helped in a very big way pave the way for America to become a space power and to go to the moon and to do the things that we're doing right now on the International Space Station. And we hope it's also going to help set the stage for us down the road to do even greater things.
Well, Dan and Don, I thank you both very much, but we're going to turn the tables on Senator Glenn right now, if it's okay with you. He's been getting pummeled with questions, and he is probably the biggest champion of the International Space Station. So I'd like to give him an opportunity to kind of pummel you with some questions about life up there, since he's campaigning already for a trip to station. So I want you to wise him up, if you will. So Senator, if you'd like to pose a couple of questions for him or some comments to them.
You guys are not floating. You got your foot in the strap? How are you secured there? You got a belt on?
Senator Glenn, it's great to talk with you. Welcome aboard.
Thank you. And he's going to hand my head to me on a platter if I'm not careful with this talk about going to the station. But no, I know you're floating around. That's one of the things you can do up there. And one of the zero-G environment, of course, is why you're up there to begin with, to do the research that can be done there. What are you doing, hanging on? Are you tethered?
Actually, I've got one foot underneath a bungee, another foot underneath a handrail. I think Don right now is free floating, and behind us is Andre Kuipers, European Space Agency, Dutch astronaut with us, and Andre's basically free floating as well. It took us a little while to kind of get our space legs, so to speak, but everybody's pretty comfortable managing their orientation in any number of ways.
Do you have any estimate, I don't know whether you know the exact number of research experiments you have on board right now. Do you have any idea of how many are on board?
I knew he was going to give it to Don.
We have well over 100, and they all come with an acronym that you either have no vowels in them, so it makes it really hard to pronounce, or you can't remember what all the words, all the letters stood for in the first place. However, I would like to say that the experiments we've got a whole ensemble of life science experiments that basically probe the gravity knob for life, since it evolved on Earth under constant gravity, and now all of a sudden we can change the magnitude of gravity by a factor of 1,000,000, and we can look at what the effects are on living organisms, including human beings, under that. And then we have physical science experiments, growing crystals, looking at surface tension and other related phenomenon that gravity masks, and then combustion experiments. I did a whole suite of combustion experiments this morning. It was really fascinating.
Yeah, are you able to keep combustion going with less fuel required? I know that was one of the things that they came up on Columbia before it was destroyed.
You know, that I don't know. I do know that you have to fan the flames if you want to keep them going up here. We're looking at forced convection, and the fuel that I was looking at this morning with help from folks from NASA Glenn was ethylene. We're looking at 20% ethylene and burning that in air under forced convection, and looking at when you get separation of the flame from the fixture that holds it.
That's very interesting. I thought those energy experiments that were started on Columbia, I thought were fascinating, and they had a lot of important future maybe right here on Earth. I don't know whether people here in the audience right here today realize, but a candle has flame goes up because the air is heated and the convection goes up and pulls the flame up. But in space, when something burns, it just collects in a big cloud around it. So you get a whole different set of burning and combustion principles than anything you can't duplicate that here on Earth. And there were some of the indications were that we might be able to have combustion with far less use of fuel on some of the Columbia experiments. And that's what you're continuing that right now, I guess. Is that correct?
Yes, Senator Glenn, and I find it philosophically interesting that civilization started with fire and learning how to use fire, and it's served us well for millennia, and we are slowly refining our understanding of what fire is, because fire will work whether or not you really understand all the details of the chemistry. Yeah. And what we're doing now is, again, using a reduced gravity environment, which changes the dynamics of combustion, so that we can dissect even more detail out from how fire works, which is obviously a needed element even as we leave planet Earth and go off into the go away from the planet.
Hey, Dan, we've got a number of very young students here with us, and I know I was watching you earlier. It may have been a replay, but the first handshake between a humanoid robot and a human in space. Can you talk a little bit about R2 and whether R2's behaving or is developing a mind of its own already?
Yeah, we were talking about that. We wanted to make sure that all three laws of robotics had been incorporated. But in all seriousness, a couple of days ago, we had Robonaut R2 out here in the lab, and we were basically doing some checkouts on it. And at this stage, really, it's a technology development program. And the idea is that all the interfaces, all the things that we have on space station that we interact with are all designed for humans, for human hands, for human arm length, for the parallax that human eyes provide, and essentially Robonaut has the same functionality, the same capability as far as interacting with hardware. So it affords down the road a very good opportunity to take the tasks that are routine and perhaps some of the tasks that might be more dangerous for crew members to do, and basically help offload us and share those tasks with an anthropoid robot. And ultimately, I think it also has a lot of promise for doing spacewalks, and those can be, of course, one of the most dangerous things we do in space.
Now, I'll put the three of you guys on the spot because I don't think the senator's ever been asked a question from space. So how about if the three of you put your heads together, play like you're a newsman, and give us a question that's really rough for him.
Thanks a lot.
And Annie's sweating beads under.
So, Senator Glenn, did you ever really find out what the fireflies were on your first orbit?
Yeah, we did. I think Scott Carpenter on the second flight was able to hit the side of the spacecraft, the capsule, and send a whole shower of them out. And the scientists working on this, they could relate them to the water dripping out through the heat exchanger, which was a controlled thing. And then they just collected in a large cloud around the spacecraft. The one thing I don't know that scientists have ever figured out yet is why the glowing luminous color. Water particles will go out and freeze, and then the light comes from the sun and through the Earth's atmosphere and back out to the spacecraft again. And what changes the light in that, what is refracted there so that when it hit these frozen particles, they glow sort of a glowing luminous color. And I don't know that we ever figured that one out. If we do, I don't know what the answer was on it, but they weren't anything that was going to do me any harm, so I wasn't too concerned about them.
If you guys had an opportunity to bring this, since he's bugging me all the time, if you had an opportunity to bring him up for, say, a couple of months stint on station, okay, Annie, I'm just kidding. Which experiment that you're doing now would you most like to hand off to him, and why?
You know, one thing that we didn't talk about already, which I think is a key thing that we're doing on board Space Station right now. We do a lot of the life sciences and physical sciences, but one thing that we're doing on station really, I think, falls in the category of engineering development, technology development. And I think this is some of the key things that'll help us leave low Earth orbit, go on to the moon, asteroids, and onto Mars. And I think one of the things that we learn an awful lot about every day that we get a chance to interact with it is the regenerative environmental control system that we have here. So I think, based on his experience, the Senator's experience, it would be really neat, very interesting to get a chance to work with him on the systems that we have to provide that capability. If we spend so much time sometimes focused on the details of those tasks, it would be really good to have a big picture look on about that, and also from somebody who has thought about leaving low Earth orbit from the perspective of lawmakers in our government.
And really what Dan meant to say was, when he was talking about the regenerative life support system, that's a fancy word for our toilet. And so he wants to put Senator Glenn busy fixing the plumbing up here.
That's exactly what I thought I was going to get assigned to. Thank you.
And I think now that Don's pointed it out, I may find myself replaced outright with the Senator.
You got anything else for the
Yeah.
crew there?
One other question. Do you have any plant growth studies on board right now? Because those are fascinating too.
Well, just as a little investigation on the side, I've been growing a few plants, and as Senator Glenn, I was able to get a zucchini plant to bloom, and it bloomed on Valentine's Day, and I had a special conference with my wife, and I presented her with a zucchini flower. I mean, it's not a rose, it's not a lily, it's not a carnation. It was a zucchini blossom, and she could only see it on the downlink video. But I did pick that blossom, and I stuck it in our World Atlas. I'm pressing it between pages, and I'm going to bring that home and give it to her.
That's good. Great.
Everybody went, oh. Hey, we're here for a future forum. So for the next,
One thing.
go ahead.
Just so everybody here, I wonder about how far around the Earth they've traveled just while we've been talking to them. Probably a fourth of the distance around the Earth, just in the time we've been talking.
Either of you watching the map?
And I'd say that's about right. So it's been basically a fourth of the way around the Earth. So in the order of about 10,000 kilometers thereabouts.
Yeah.
Quick question for you. As I was saying, we're here for a future forum for the next day and a half. You know, just from what you've seen so far, what would you like to be a topic that this group considers in terms of where should we be 20 years from now or 30 years from now, based on what you've seen and experienced this time? And you know, I know it's your second time up there, Don.
Well, I think there's a lot of aspects to that. And I think one thing that, one of the biggest challenges that we have on board Space Station that we've probably had in any spacecraft before, and it's something that with the Space Shuttle, we really didn't have this case. In the Space Shuttle, every time we flew it, we returned it to the factory in essence. We returned it to the people who knew how to build it. On board Space Station right now, astronauts have to be essentially jacks of all trade. We need to be able to fix anything and everything that happens. We need to essentially be professional technicians on a par with the people that for decades have put their heart and soul into taking care of incredibly complicated and exotic vehicles in the form of the Space Shuttle. If we leave low Earth orbit, one of the key things, one of the most important things I think we need to have is we need to have the capability to essentially cut the umbilical, to be able to maintain spacecraft to the degree that if something breaks, you can replace a part outright. You need to be able to fabricate a part. You cannot bring with you all the pieces and parts that you might anticipate that might break over the course of a couple of year mission. So one of the key technologies, and it's something that I think is a unique need for spaceflight, is to find some way to be able to fabricate parts that we can replace, and to be able to do those things, obviously in conjunction with the ground, that's going to help you, talk you through those things remotely, but the fabrication part and the repair capability is one of the biggest challenges I think we have.
And then I think that one aspect of going away from Earth that we need to think hard about is, do we take everything with us on the mission from planet Earth? Do we lift everything we need from Earth's gravity well? Or do we figure out how to take materials from elsewhere and use them to enable missions? And this all boils down to what I refer to as the tyranny of the rocket equation, and what the engineering implications are to the rocket equation for the design of our rockets that we launch from the surface of Earth, and the implications of how much payload can any given rocket take up, and what do you use for that payload. And when you look at building bases elsewhere, it's going to take hundreds of tons of material to build and maintain a base, and how do we get those hundreds of tons of material up into space? And I think we need to do some serious thinking about the rocket equation, maybe alternate ways to try to get things into space that don't necessarily use the rocket equation, and possibly think about getting materials, brute force and ignorance materials that we need by the multi-ton from other than planet Earth.
Don, let me ask you one. Go ahead, Andres.
Let me ask you one. Go ahead, Andres.
Yes, as an international representative of the international partner, I think it would be nice to add the question to the future forum, how the future is going to be in the sense of international cooperation. We work together with a lot of partners here now, and I'm curious what the forum thinks about going beyond Earth orbit as an international effort.
Fantastic. I appreciate that, because I'm thinking about it. We don't have a lot of time left, but let me ask you all to just tell all of us, if you can, we're getting ready to send the first private spacecraft up to get ready to bring you supplies. What type of training are you doing to stay ready there on board in case, the Dragon or Cygnus happens to get there during your watch?
That's a great question, and it's really important for us to be able to maintain currency, and that comes right down to the piloting skills of being able to do a robotics capture of a free-flying vehicle. And should SpaceX Dragon make it here during my watch, and I hope it does, the way we're keeping ourselves current is by practicing using a program called Robot, and that is essentially a robotics simulator that uses some of the tools we already have developed at Johnson Space Center by folks that work in the virtual reality lab there. And those tools allow us to essentially simulate the environment right down to the dynamics of how the space station robotic arm works, the dynamics of the motion control system of Dragon, and very high fidelity graphics. And it allows us to essentially go through all of the crew coordination skills and the monkey skills of flying the arm right up to capture. And we can do it multiple times. In addition to that, we can also do dry run captures using the real space station robotic arm to grapple fixtures on space station. That's something we have done a couple of weeks ago.
Hey, I want to thank you guys. I know it's, you're really busy up there. I appreciate you taking time to just help us entertain this crowd here, and I'm going to turn it over to Senator Glenn for a final farewell.
Well, this is really a great surprise this morning. I didn't know I was going to have the honor of talking to you guys up there, and I just was sitting here thinking a minute ago about how technology has gone ahead so rapidly in the space age, because here we are watching high-definition television here, and you guys coming through perfectly. Back in the Mercury days, we had to go over each station on the ground apart and couldn't even keep communications. Now we have the TDRS Technical Data Relay satellite that you relay through, so you have constant communication around the Earth. It's just amazing that we can sit here and talk to you back and forth. So thank you very much for helping kick off our forum. It's really great. Congratulations to all of you. Thank you.
And from and I guess from the Ohio State University, I'm learning.
You're
okay.
learning.
the home of the Buckeyes. We're going to pass it back to Houston and let you guys go about your work. But thanks again. This has just been incredible for us. Thanks so much.
Thank you so much. It's been an honor and a pleasure for us as well.
That's amazing.
It is.
Yeah.
Fantastic.
Well,